Hello students, this is the intro lab for lab number 9, and what we are going to do today is it's going to be two parts. The first one is superconductivity, and the second one is verifying the Ohm's law. So for the first experiment, we have a ceramic superconductor here, and we are going to pour the liquid nitrogen into this tray to decrease the temperature to achieve the superconductivity. So before doing the experiment, we have to set up the measurements here. We're gonna need a voltmeter, which will measure the thermal conductivity on the ceramic superconductor. And then from this thermal conductivity, you can convert that into the temperature. The second voltmeter will measure the voltage across the device, and the third one will be an ammeter. It will measure the currents across the superconductor. Now we are going to set it up by connecting the power supply into the system, and then setting this multifunctional meter into a voltmeter, this one into a voltmeter too, and the third one will be an ammeter. So you can see that for this one we are having 0.3 amps, which is the required current for this experiment. And we have 2.2 volts here, which is the voltage across the superconductivity, and then we know that when we have superconductivity, this voltage will drop to 0. And for this one, the thermal conductivity now represented by 0 millivolts, but when the temperature decreases, it will become around 6 millivolts. So now what I'm going to do is to pour the liquid nitrogen into this tray. Before that, we have to put the cord into the hole here to prevent the liquid nitrogen from draining out. Okay. Now as the temperature decreases below the critical temperature, we have a 0 volts here, which means that superconductivity is achieved. And the thermal conductivity here now is 6.4 millivolts, which means that the temperature is around 70 Kelvin. And as we are having superconductivity, we can check that by putting this magnet cube onto the superconductor. Can you zoom into this?
Yep.
And then it can be seen that this cube is being levitated. We can spin it. So this is superconductivity. And then we are going to investigate this by increasing the temperature again. And then we are going to remove the cord to let the nitrogen drain out. And as the temperature increases again, we'll see that at some point this magnet will drop, and the thermal conductivity here will decrease to 0 at some point, and the voltage here increase. It will jump from 0 to some value around 0.5 or 0.7 at some point. So what we are going to do is to record all of these data here, and then record the point when we have the magnet drops. Yeah, you can see that it drops already. And then we will record all of these data of the voltage, the thermal conductivity, the voltage, and the current here, put it into the table, and then make the analysis later. Alright, for the second part of verifying Ohm's law, the first experiment will be measuring the voltage and the current across one single resistor. So we are going to use this 1 kilo ohm resistor, and we're going to set up the circuit according to the figure in the manual. Starting from the power supply here, connected into the red node on the resistor, and then goes back to the negative terminal. So this is the circuit, but then we have to connect these voltmeter and the ammeter into the circuit. So we know that the ammeter should be connected in series with the resistor. And what I'm going to do is connect the output of the resistor into the ammeter input, and then from the ammeter it goes back into the negative terminal of the power supply. And then we turn it on using the ammeter mode here. For the second one, which is the voltmeter, we are going to connect this in parallel with the resistor, which means that they will be connected in the two nodes across the resistor. And then set it into the voltmeter mode. Now we are going to turn on the power supply here, and then we can use this knob to adjust the voltage supplied into the circuit. So what we are going to do is to adjust the power supply here and then record the voltage and the current across the resistor, then put it into the table. Then you are going to plot the graph and then analyze this data, in this case. Yeah. For the second experiment, we are going to replace this resistor by the light bulb here. So we just disconnect this resistor and then replace it by the light bulb. Like that, and then you are going to vary the power supply into the circuit. Remember that the maximum supplied here should be lower than 6 volts. And again, what you're going to do is to record the voltage and the current, put it into the table, and then plot the graph. And what you should see here is the VI relation should not be a linear relationship, but it should be something else because of the heat effect on this light bulb. So for the third experiment, we are going to make resistors in series circuit, and we are going to use these two resistors. First, we are going to set them in series. Start from the positive terminal here into the first resistor, then into the second resistor, and then into the ammeter. Then it all goes back to the negative terminal of the power supply. Then we are going to put 2 voltmeters to measure the voltage across these 2 resistors. So the trick to do this is that to have 2 wires connected into 2 terminals of the voltmeter, and then connect them into the 2 other ends of the resistor. Now we set them up into the right mode, ammeter here, and then voltmeter, then another voltmeter. And then we adjust the power supplied into the circuit. What we are going to do here is the same as the previous experiments, which is monitoring the voltage and the current across the 2 resistors, and then put into the table and then analyze the data. The last experiment here is resistors in parallel, which is the current divider. In order to set up that, we are going to divide the current from the positive terminal of the power supply here. One will go into the first resistor and one will go into the second resistor. Then after that, there will be ammeter in series with this resistor. Put it into this ammeter, and then it all goes back to the negative terminal, which is here. For the second branch, it will be the same thing. Will be connected an ammeter in series with this resistor, and then it all goes back to the negative terminal of the power supply. So in this experiment, we are going to need one more ammeter to measure the IPS, the total current, and we are going to use another ammeter here, set it into the main line of the circuit. Put this into this ammeter. And then connect it to the negative terminal of the power supply. Then we are going to increase the voltage of the power supply here. And what you are seeing here it shows that the sum of the two currents, I1 and I2, will be equal or closely equal to the total current. And then you are going to vary the voltage here, and then monitor the data here, put into the table, and then analyze the data.